Okay, today we're going to look at some common problems with historic 2D seismic data and how to solve them. And so you can see here I've got a seismic line. Here's a strong reflection near the base. It's actually in the Karoo Basin. At the bottom here is basement. And it doesn't look too bad a seismic line. Over here something looks a bit wrong. But the main time you start seeing problems is when you view it in 3D. So if I right click on here and I say display current line in view pack, so I'm using Kingdom Suite, you'll see that as soon as it loads, you can notice a bit more clearly these vertical lines where there's like stretching. I'm starting to realize is a common indicator that there are problems with the coordinates of this 3D line. Sorry if I'm making you dizzy, but yeah, you can see here something's wrong. And so how do you fix those problems with the coordinates, and is it fixable? And it really is. It's not a difficult problem. So from this side you can see those two vertical lines. And so let's go about how to solve this problem. So first thing to do is to get these coordinates into a plotting program like Geosoft and just see where they are, what it looks like and where the problems lie. And so if you don't have Geosoft, there are tons of other programs, but Geosoft is just the most convenient. And so in Kingdom Suite here, I'm going to open up, click on, oh wait, I have to close that first. In the menus here, I'm going to click on Surveys and I'm going to go Size Direct. And I'm doing this so that I can copy and paste the XY coordinates that are in the header of the SegWi file. And so I forgot to mention at the start that this is really just assuming you don't have a navigation file, which is very often the case, and that your coordinates are in the header of your SegWi data. And so the first time you open up Size Direct here, you've got to define which folders your seismic data are in. So you can see I literally call mine seismic data. This next part here, directory containing SegWi files, you could use this overall folder, but then you're going to get every single seismic line in that folder. So I have taken it one step further here and gone into the folders where the data for this project are. And then I click on OK. Then I click on Explore over here. And you can see it's got the folder structure within that folder up here, and these are the sections of the lines, and it's the original data the shot gathers, and then these are two different processed versions of the line. I'm going to click on the migrate folder here, and you can see this is the SegWi data within this folder, and this is all the header information stored in the SegWi file. If you're not used to SegWi data, it takes a while to get used to, but at the top here is the text header. It tells you stuff about the line and processing. Sometimes there's not that much information here. Yeah, often it's left out. At the bottom here is some more information that is stored in columns or in bytes. And so you can see here, this first one is the CDP number, shot point number, goes all along to XY location, and so forth. We'll look at the next screen that gives you a bit more options with this. And you can see here that your CDP value goes from 1 at the top all the way down to 500, so there's 500 common depth points. And you can see that these two shot points are the same, shot point 1, but there's different common depth points. And you can see here this X and Y location, because it changes, it's most likely the CDP value. But let's not get into too much detail now. Click on the top here, click on this export button, and a new window will open. And you can see here it's a bit easier to understand what's in the different columns. So you can see here byte 1 to 4 is the trace number line, which I'm not too sure about, but you can see here 17 is the shot point number, so I'm going to click here so that it displays on this side. CDP number I'm going to click on, source point, and then down here I'm going to choose source X, source Y, is R, receiver X, receiver Y. Also, if you scroll down to the bottom, there should be CDP X and Y, though these don't always have understandable values. Here's shot point. So there's source point and shot point. I'm not always sure what half of these things mean. But I just wanted to point out here, CDPs have no values in them, and so yeah, sometimes columns can be left blank. This shot point thing has also got no values in it. So I would assume then that these values in the source X, source Y are actually your CDP X and Y's, as they change from each line. And if you actually look across here, I think your receiver X and Y's are the same as your source X and Y's. So don't always take your header values at face value. So don't just assume that what the heading is for the value is the correct label. Very often they aren't, and you've got to really just go through your data and try and understand your data. So I'm going to assume that the source X, source Y is the CDP values. And now I'm going to take these values and put them into Geosoft. Just to warn you, do this slowly because it often crashes the program and you've got to close down the whole kingdom. So you click on this first source X value and then hold down Shift in your keyboard and scroll down. And when you get to the bottom, hold down Shift, click, and you get the whole column. Control C on your keyboard. And now I'm going to open up Geosoft. I've already got a program. I've actually done this already, but let's do it again. So I'm going to create a new database. Be sure to give your database name. Make sure you add there what segwire file you got the info from, because at a later date you'll have no idea where you got the info from. Click OK. Yeah, I'll just overwrite it since we're going to do it again. And so now I didn't speak about this, but I can tell you that my coordinate system is LO27, and it's just from experience I've had working that I know the value should be 80,000. And the main thing is, you'll see if we go back to let's just run Seismic Direct. The main reason why it's quite easy to see is that the Y values are in the millions here. We've got 3 million, is that correct? Yeah. It should actually be negative, so obviously the negative's been removed just for convenience in the header, so we'll have to add it back in, and then I'm going to paste that here. So in South Africa we have our own coordinate system that often the mines used, and it's this LO coordinate system instead of UTM, so it gets a bit complicated. And sorry, I keep on doing that wrong. And I'm going to take the CDP values. I know most of you are like, oh, why don't you just copy from the bottom? I'm so careful of this program crashing. I scroll to the top every time and hold down Shift and scroll to the bottom and copy. So just be careful, it really does crash. And I go back here and I paste my CDPs. And then obviously I have to define my coordinate system. I'm actually not going to do that first. I'm going to add in the negatives first to save us having to do it twice. So sorry, I didn't speak about that. You've got grid maths under database tools in Geosoft, and you can literally just multiply by a negative. So you can see here my new column that I'm creating. I've written it, typed in that header, and I'm literally taking the existing column and multiplying it by -1 I typed in this equation. And I click OK, and it shows up here. And then I'm going to do the same for the Y column. This showed up automatically because I'd done it already. You'll have to type it in if you're starting from scratch. So literally I'm going to take the Y column and times it also by a negative. And then these are my X and Y. Now I have to tell Geosoft what my X and Y's are, so I'm going to go coordinates and then coordinate system. You can see it's chosen the negative X and the negative Y as my X and Y. I click on coordinates. And here I've got to define the projection, so I click on projected. So the other complicated thing about LO is that in 1999 in South Africa they went from using the Cape datum to using the Hutterbeershoek datum, which is similar to WGS84. And so you can see here at the top of this list it says South Africa survey. This is LO, and I know I'm in zone 27 in this area. And then datum, I'm choosing Cape, but if you've got data that's newer than 1999, you would actually go here and choose Hutterbeershoek, which is a little bit further down here, Hutterbeershoek 94. Okay, if you do this wrong, it is not a train smash, but when you plot your line on Google Earth, you will be 300 meters off of wherever they collected the data, and usually they collect the data along a road, so you're usually 300 meters off from the road. So that's how you know that you've done this wrong. So I'm not sure if I'm doing this right. I will go and check it later, but I'm making an informed guess. And now I'm going to plot this data on my map behind me here. So you go Map Tools, Symbols, Location Plot. So it's in meters, so I choose a masking channel. I'm going to just choose the X. I'm going to plot dots quite small so that I can just see individual dots. I'm going to click OK. I'm not going to rewrite it because I have done it already. And then it plots it on the line here. So you can see there's the line. It's not super clear, but we'll zoom in. This background data is elevation data. I just wanted to check that if there's a gap in the line, it's not due to a hill, that it's more likely human error. So the problem with historic data is you very often don't have navigation files, observer files, so you don't know if there was a gap intentionally or not. So you have to make informed decisions. And so let's zoom to the beginning of the line here. So I'm going to have to zoom in a little bit more. Okay, I'm going to go back to my database here. I'm actually going to put these next to each other. I just wanted to check what is my distance between each point. What is my shot point distance? Okay, database tools, channel tools, make a distance channel. I'm using the X and Y values. I'm going to call my channel dist, and I click OK. Okay, and you can see there's approximately 25 meters between station spacing. So you can see we're going along. So if I click on my value in my database here and I scroll down, you can see how it's moving on the map. And you need to do this because you need to double check that there's no duplicate points, that there's no values on top of each other. I mean, you can do it in other ways. You could minus the second value from the first, and your answer in the next column should always be 0, and if it's not 0, then you know that there is duplicate. But I just visually want to go through the data. And this is where we come to our first problem here. So let's go. You can see I'm over here at CDP point 58. I go down to 59. It's skipped a station at least. And then I go down. I go down some more, and you can see it actually stays at this CDP point for three times. It's got 3 stations, 3 of the same CDPs. And then it goes down to the next CDP, and it stays there also for 3 duplicates, or actually 4 duplicate CDPs over here. So it's there are 2 options. Either there's really something they did in the field that makes it have this many CDPs. Most likely though, it is a problem somehow with the coordinates, and you would expect that, how many points do we have here? It's 1, 2, 3, 4, 5, 6, 7. Those 7 CDPs should actually be spread out in this gap over here. But let's keep looking and see if there's any other problems. So it becomes quite tedious. You really are just going to scroll through your data, and I would make a note. So I'm going to write down over here. Except I can't find my pen. Over here. I'm going to make a note here that at CDP, around CDP 60, that was where I noticed my first problems. Okay, and let's keep going down. Okay, if you click on your map and click P on your keyboard, you can scroll up, you can drag the map up, and let's keep going. We've got a problem coming up ahead. Okay, I'm going to scroll down so we can just see the numbers. So it goes from CDP 177, it jumps to 178, and it stays at 178 a bit, it goes 179, stays there a bit, jumps to, it says 185. So I mean your CDPs are numbered as ever increasing, but your X and Y values are staying the same. So there definitely is a problem. And again, so pretty much, let's just check from here. So from CDP 193, and let's jump up again. Oh, it's always a problem when you delete stuff. So CDP 178 to 193. 178 to 193, we've got a problem. And so I'm not going to bore you by going through this whole thing, but you need to make note of these, and we're actually going to have to go back and copy your database so that you don't rewrite your original, but actually fill in these gaps and fix the coordinates. But I just want to show you something. So here we're at CDP 175. Let's see if we're actually seeing this, or 177. Let's see if we're seeing this in our seismic data. So we go back to Kingdom and we go back to our view pack. And you can move your mouse along and it should show you at some point here. If I'm moving along, you can see along the bottom of the screen. I'm assuming that cross line is the CDPs. So it's over here, so it's not that clear to see. I'll show you a better example now. I think it's possibly such a small problem, a small region, that it's not really picking it up. So how about, so that you don't get bored, let's jump to these regions here and see what the X and Y's look like. Where do they plot, and why is it causing this trouble in the data? And so if I put my mouse over, it's telling me that it's at cross line 1800. So let's just triple check if that's a CDP value. So if we scroll down in Geosoft to 1800 over here. So now you can see, obviously on the map it's gone off the screen, so I'm going to push the world button and zoom out, and that's where 1800, CDP 1800 is. And I'm going to zoom in, and you can immediately see what the problem is. It's that you've got possibly, I'm just trying to think about this line, was it two lines merged, or why do you have CDPs going off in that direction and coming down here? Is it because, I'm not even sure. So the big problem is, you can try to figure it out, but and to realize that whatever you fix is not always going to be the honest truth. Unless you've got observer reports, it's going to be very difficult to actually solve this problem. But you're going to do the best that you can, but just accept that it might introduce errors into your data. So I'm going to zoom in a bit more just so we can see where things move around. Okay, so on the left hand side here, you can actually see on your map these CDPs are very close together, whereas before they're a bit more spread out, although there's problems there as well. Okay, well let's just move along and see how it goes. You can see it stays at that point for several coordinates or CDPs, jumps down there, stays down at the bottom for a very long time, moves down. I'm interested to see where exactly these lie in the data. So it's going down the line. Okay, so can you see there, your coordinates went from down at the bottom there to jumping up to the top here. And that is the problem in the 3D, when you're viewing your seismics in 3D, because it's actually stretching the data to fit the coordinates. So you don't notice it as severely in 2D, although you do vaguely, but it's not as bad. So let's just triple check where is this point on the 2D data. So it was 1800. And you can see this is this like tear in the data. So now the thing is, how do you fix your coordinates? And it definitely takes time and a bit of effort. So let's just scroll down. So this region is quite a problem. So let's go here. Something else that I think I remember, if we zoom in, but it might just be a graphics thing. No, it just seems to be a graphics problem. So yeah, just lots of gaps here and there, possible duplications. You can see there's points side by side, more gaps. So I think, like we showed the first example, they don't affect your seismic data too much. There's small gaps, but it's when there's these big overlaps that there's a bit of a problem. Here as well, you can see, if you click on this button here, data linking, and you choose the database that you've got open, when you click on the point, it takes you to where it is in the database. So it's down here at the bottom. So we're getting, that's the end of the line there. So let's click on it. Oh, sorry. And anyone knows how to undo accidental inputs, let me know. And you can see there's a bit of a jump there. These are all quite close together. So you can see a jump from that point to that point, back up, goes down. So it's not going back on itself, but there's definitely problems with the spacing, which I could understand if it was an erratic line, but I don't understand why it would go out. So let's see what happens if we make the assumption, and it's a big assumption, that CDPs should be exactly 25 meters apart along the line, following the same pattern of the line, and see what the seismic data, how different it looks. I don't think it's going to look that different on this line. I will show you an example of another line where it drastically changed the line, because on that line the order was completely wrong. Instead of going from north to south, it jumped from north to south and south to north, and it was an absolute disaster. So this isn't a bad line, but it definitely is going to change your data somewhat.